Okay, we start with this question. Y is equal to tan inverse of cos x minus sin x divided by cos x plus sin x. Okay, so since it is tan inverse outside, the expression inside should reduce to something in tan. So I have tan inverse outside, so I want something in tan inside. And we know that every tan formulae actually starts with 1 in the denominator. So I want to have a 1 here. And also, it makes sense, like if I try to make this 1, that means I'm going to divide by cos x. So in the process, this sin x would become sin x by cos x, which is tan x as well. So that's what we are trying to do here. We want to make it into something in tan, and for that I divide each term by cos x. The logic is that I need the first term in the denominator to be 1, so I divide each term by cos x. So dividing each term by cos x, so let's see what you get then. Y is equal to tan inverse of cos x by cos x is 1 minus sin x by cos x is tan x divided by cos x by cos x is 1 and sin x by cos x is tan x. Now I want to make it match with one of the tan formulae, probably tan A minus tan B divided by 1 plus tan A into tan B. So what I do is I'll rewrite 1 as tan pi by 4. So tan pi by 4, which is 1 minus tan x divided by 1 plus this simple tan x, I'm going to read it as 1 into tan x, but 1 is tan pi by 4. So I'll write it as tan pi by 4 into tan x. So it's actually the same expression. Tan pi by 4 is 1, so 1 minus tan x divided by 1 plus 1 into tan x is also tan x. So 1 minus tan x by 1 plus tan x. But at the same time, it now takes the form tan A minus tan B upon 1 plus tan A into tan B. And that's going to be tan of A minus B. So this is going to be tan inverse of which is there outside, and this whole thing becomes tan of A minus B. So tan of pi by 4 minus x. Now tan inverse and tan will cancel, so I have just pi by 4 minus x. So y is equal to pi by 4 minus x. So I say differentiating with respect to x, dy by dx is equal to pi by 4 will become 0, and the derivative of minus x is minus 1. So looking at this question here, this is y is equal to tan inverse of root of 1 minus cos x by 1 plus cos x. I think you should do this as homework. Pretty direct question. 1 minus cos x has a half angle formula, 2 sine square x by 2. 1 plus cos x has a half angle formula, 2 cos square x by 2. So you will replace 1 minus cos x by 2 sine square x by 2, and the denominator 1 plus cos x by 2 cos square x by 2. Next question, y is equal to tan inverse of sec x plus tan x. So here when I see sec x plus tan x, I know that there is possible simplification on it, because we always try to change every single trigonometric function which we get in terms of sine and cos. So this is going to be tan inverse of sec x can be written as 1 by cos x, and tan x is sin x by cos x. So we try to put them into the lowest form in terms of sine and cos. Sec x 1 by cos x, and tan x is sin x by cos x. Now I take LCM, common denominator is cos x, so I'll get 1 plus sin x by cos x. So this is going to be tan inverse of 1 plus sin x by cos x. But then we realize, unfortunately, we don't have a formula for 1 plus sin x, but 1 plus cos x has a formula. So I know that I have to change sin x into cosine, a cosine term, and sin theta can be written as cos of pi by 2 minus theta. So sin x can be written as cos of pi by 2 minus x. But if I change the angle in the numerator, then I need to change the angle in the denominator as well, which means cos x should be written as sine of pi by 2 minus x. So it's going to look like this, tan inverse of 1 plus cos of pi by 2 minus x. I rewrite sin x as cos of pi by 2 minus x. divided by cos x as sine of pi by 2 minus x. Now both 1 plus cos x and sine x, 1 plus cos theta and sine theta have got half angle formulae. So we try to apply those formulae. 1 plus cos theta is 2 cos square theta by 2 and sine theta is 2 sine theta by 2 cos theta by 2. These are the two half angle formulae which we know. We are going to apply them. 1 plus cos theta is 2 cos square theta by 2. 1 plus cos, this whole thing is my theta. So 1 plus cos theta would be 2 cos square theta by 2. Half of this angle. Pi by 2 will become pi by 4 and x will become x by 2. So it's going to look like 2 cos square theta by 2 pi by 4 minus x by 2 divided by sin x or sin theta is 2 sin theta by 2 cos theta by 2. So sin theta, this whole thing is my theta, pi by 2 minus x would be 2 sin theta by 2, half of this angle, which is pi by 4 minus x by 2 into cos theta by 2, pi by 4 minus x by 2. Little bit of simplification possible. 2 and 2 will cancel. Cos pi by 4 minus x by 2 from the denominator will cancel with one of the cos terms in the numerator. So what you have is cos pi by 4 minus x by 2 by sin pi by 4 minus x by 2, which will be cot pi by 4 minus x by 2. But then again we have a small problem. I have tan inverse outside, but inside it is cot. Tan inverse and cot won't cancel. So I'm going to change tan inverse into pi by 2 minus cot inverse. That's a formula. So I'm writing that formula here. Tan inverse of x can be written as pi by 2 minus cot inverse of x. So tan inverse of this whole thing will be pi by 2 minus cot inverse of the same thing. So I'm going to rewrite it that way. Pi by 2 minus cot inverse of this whole thing, which is my x. Tan inverse of x is pi by 2 minus cot inverse of x. Tan inverse of so much would be pi by 2 minus cot inverse of so much. Now cot inverse and cot would cancel. So pi by 2 minus cot inverse and cot will cancel. What balance is pi by 4 minus x by 2. I'll open the bracket. Then I'll get pi by 2 minus pi by 4. 90 minus 45 is 45. Pi by 2 minus pi by 4 would be pi by 4, and minus into minus is plus x by 2. So I get it as pi by 4 plus x by 2, and then I differentiate. So my question y is now just pi by 4 plus x by 2. The question is asking you to differentiate. So we'll say therefore dy by dx is equal to pi by 4 derivative is 0, x by 2 is 1 by 2. This is y is equal to cos inverse of 3 cos x minus 4 sin x divided by 5. We do this question in a very special way. You should remember that you need to divide them separately by 5. So we write it as the first term divided by 5 minus the second term divided by 5. But we rearrange it as 3 by 5 cos x minus 4 by 5 sin x, dividing separately by 5. Now we know since it is cos inverse outside, the inside expression should be something in cos as well. So we try to match it with one of the cosine formulae. And what would go here is cos A cos B minus sin A sin B, which is cos of A plus B. So I'm going to treat it like cos A into cos B minus sin A into sin B, which would change to cos of A plus B. So which means I'm going to call this as cos A, and then I'll prove that for that particular A, this will be sin A. So I'm going to say let this be equal to cos A, and when I calculate sin A, I should be able to prove that it is same as 4 by 5. So I'll say let 3 by 5 be equal to cos A, and therefore sin A would be root of 1 minus cos square A. 1 minus cos square A is sin square A, root of that is sin A. And then I know what cos A is. Cos A is 3 by 5. So 3 by 5 the whole square, which is 9 by 25. Take LCM. 25 minus 9 is 16 by 25. And root of 16 is 4. Root of 25 is 5. So if cos A is 3 by 5, then sin A is going to be 4 by 5. So I'm going to call this as cos A. Then this turns out to be sin A. So what would my expression now become? It will be cos inverse of cos A into cos X minus sin A into sin X. Cos A cos B minus sin A sin B is cos of A plus B. Cos A cos X minus sin A sin X would be cos of A plus X. Now cos inverse and cos would cancel, so what you have balance is just A plus X. A, what is A? We made a substitution here, so go back and look at your substitution. Cos A is 3 by 5, so what is A going to be? A will be cos inverse of 3 by 5 plus X would stay. So I replace A by its value. Cos A is 3 by 5, so A would be cos inverse of 3 by 5 plus X. And at this stage, I will differentiate. Your question is basically to differentiate. Therefore, dy by dx is equal to cos inverse of 3 by 5 is 0 plus x would become 1. So the answer is 1. You have a question for homework here. Y is equal to cos inverse of 2 cos x plus 3 sin x by root 13. It's exactly the same way. You will divide them separately by root 13. Then make the substitution. Look at the question which we discussed already. Do it 2-3 times and then you try this question. Should be able to do it. Looking at this question now, y is equal to sec inverse of root x plus 1 by root x minus 1 plus sin inverse of root x minus 1 by root x plus 1. This is a 2 marks kind of a question. I have a sec inverse of a by b. We know that sec inverse of a by b is the same as cos inverse of b by a. So if I make this a by b into b by a, that would be cos inverse. So I'm going to write it that way. So this is cos inverse of the reciprocal. Root x plus 1 by root x minus 1 now becomes root x minus 1 by root x plus 1. Sec inverse of a by b is equal to cos inverse of b by a. Plus the second term we keep the same. Now this looks like cos inverse of x plus sin inverse of x, and cos inverse of x plus sin inverse of x would be pi by 2. So that's a result also. Cos inverse of x plus sin inverse of x is equal to pi by 2. And if this changes to pi by 2, derivative, your question is to differentiate. Derivative would be 0 because derivative of a constant is 0. Another question here, y is equal to root of 1 plus x minus root of 1 minus x divided by root of 1 plus x plus root of 1 minus x. This is similar to the question which we did at 122. If you go back and see the previous video, we have a question on it, which was tan inverse of root of 1 plus x square minus root of 1 minus x square by root of 1 plus x square plus root of 1 minus x square. And we said if both 1 plus x square and 1 minus x square is involved, make x square is equal to cos theta. But here I have both 1 plus x and 1 minus x in a question. Then I'll say let x be equal to cos theta. You replace x by cos theta, then the simplification would be exactly same as 122 in the previous video. Practice it and then come back and complete this question exactly the same way. And do not forget to differentiate at the end because these questions are basically to differentiate. Y is equal to sine inverse of x square into root of 1 minus x square plus x into root of 1 minus x raised to 4. Find dy by dx. So what we are going to do here is, your question is to find out the derivative of this function. Since I have sine inverse outside, I want to make the entire expression inside to reduce to something in sine. So is there any sine formula matches with that? Maybe something very close to this we have sine A cos B plus cos A sine B is sine of A plus B. Sine of A plus B, sine A cos B plus cos A sine B. So it somewhat matches with that. If provided I make the correct substitution, like x square should be sine A and this whole thing should be sine B. So let x square be sine A and this whole thing be sine B. No, that's not the correct substitution. X square is equal to sine A sounds good. But this whole thing is equal to sine B. No, no. So what I would do is, if I need this whole thing to be sine B, I know inside it has to be sine square B. But it looks like 1 minus x square. So I should choose x as cos B. And if x is cos B, 1 minus cos square B would be sine square B. Root of that would be sine B. So I will get sine A. Oh no, I need this to be cos B. If I need this to be cos B, inside the radical sign it should be cos square B. And if I want to get cos square B, it has to be 1 minus sine square B. So x is equal to sine B. So x square is sine A and x is sine B. I know this is a little bit difficult to understand because this is what I am looking for. I know it's sine A there into cos B plus cos A into sine B. So one substitution is very clear. Let x square be equal to sine A. The next one is the difficult one, which you need to remember as x is equal to sine B. But of course there is a logic in it. If I choose x as sine B, 1 minus sine square B would become cos square B and root of cos square B would become cos B, so that I have sine A into cos B. So you need to figure out that substitution. And then your question becomes y is equal to sine inverse of x square is sine A into root of 1 minus x square. X is sine B, so x square is sine square B plus x is sine B into root of 1 minus x raised to 4. I'm going to read this x raised to 4 as x square the whole square, and x square is sine A. So this is going to be 1 minus x square the whole square. X square is sine A. So 1 minus sine square A. Now it is easy. This is the difficult step. The rest of it is very simple. Sine inverse of sine A into, this will become cos B, because 1 minus sine square B is cos square B, root of that is cos B, plus this radical term, 1 minus sine square A will be cos square A, root of that is cos A into sine B, cos A into sine B, which is sine of A plus B. So I'll get sine inverse of sine of A plus B. Sine inverse and sine would cancel, so I'll get just A plus B. Replace A and B by its value. So what is A going to be? From your substitution, A would be sine inverse of x square and B would be sine inverse of x. So that's my question. Y is equal to sine inverse of x square plus sine inverse of x. Your question is simplified. Now I can differentiate. Therefore, dy by dx is equal to sine inverse of x square. Sine inverse of x is 1 by root of 1 minus x square. Sine inverse of f of x would be 1 by root of 1 minus f of x the whole square into f dash of x. So sine inverse of x square would be 1 by root of 1 minus x square the whole square into 2x plus 1 by root of 1 minus x square, which you rearrange or simplify, 2x divided by root of 1 minus x raised to 4, x square the whole square, x raised to 4 plus 1 by root of 1 minus x square. I have a question similar to that here. Y is equal to sine inverse of x into root of 1 minus x plus root x into root of 1 minus x square, and you need to figure out the substitution. I know that it has to again look like sine A cos B plus cos A sine B. Sine A into cos B. Let's analyze it. Sine A, so x has to be sine A. This whole thing should be cos B. If it has to be cos B, inside it has to be cos square B. which means it has to be 1 minus sine square b. Sine square b, which means I should read this x as root of x the whole square. I should read it as root of x the whole square and say root x is equal to sine b. If root x is sine b, this x would be root x the whole square. So sine square b. 1 minus sine square b is cos square b. Root of cos square b is cos b. So I'll get sine a into cos b. So your substitution is going to be x is equal to sine a and root x is equal to sine b. If root x is sine b, x would be sine square b. 1 minus sine square b would be cos square b. Root of that would be cos b. And here when it comes, root x is sine b. This is root of 1 minus sine square a. 1 minus sine square is cos square a. Root of that is cos a. So you'll finally get sine a cos b plus cos a sine b. And the working would be more or less the same as the earlier question. You need to practice these questions. First thing is watch it again and again until you understand, and then do the homework questions.